Alright, what's up guys? In this video we're going to pick up some calculus here, and we're going to take a look at some more trigonometric integration. So I'm going to show you guys how to evaluate this integral, this definite integral from 0 to the power over 3. We got sine squared of x times cosine to the negative second of x dx. So let's evaluate this trig integral here. So the first thing we want to do is to rewrite this integral here. And I'm going to rewrite the integral as sine squared of x multiplied by, I'm going to rewrite cosine to the negative second of x. I'm going to write that as 1 over cosine squared of x dx. And now the integral becomes from 0 to pi over 3. The integral just becomes sine squared of x over cosine squared of x dx. Now, how does that help us? Well, hopefully you remember from trigonometry, one of your trig identities, or one of your reciprocal identities actually. Remember that tangent of x is sine over cosine. So that means that tangent squared of x must be sine squared of x over cosine squared of x. So what we're going to do is actually rewrite our integrand here using trig identity. So now the integral becomes from 0 to pi over 3, and the integral now just becomes tangent squared of x dx. Now, using a Pythagorean identity, I can rewrite tangent squared of x. I'm going to write that as the integral from 0 to pi over 3. I'm going to write that as negative 1 plus secant squared of x dx. And now, if we apply the sum rule for integrals, we can actually split this up and write this as the integral from 0 to pi over 3, negative 1 dx, plus the integral from 0 to pi over 3, we'll have secant squared of x dx. And we can deal with these integrals individually, one by one. Let's just go ahead and do that. So from 0 to pi over 3, we got negative 1 dx. So I'm integrating a constant with respect to x, although it is negative. So this should just be negative x evaluated from 0 to pi over 3. So I simply get negative pi over 3 minus 0, which obviously gives me negative pi over 3. Okay. And now we deal with the next piece here. So from 0 to pi over 3, we got secant squared of x dx. Okay. Well, the antiderivative of secant squared of x with respect to x is just tangent of x. So we'll just have tangent of x. And we evaluate it from 0 to pi over 3. Okay. Now remember that tangent of pi over 3, is going to be the square root of 3. Tangent of 0 is 0, of course. So we're just going to get the square root of 3. So all we have to do for our final answer is actually combine both parts. So for our final answer for this trig integral, we're asked to integrate from 0 to pi over 3. We're asked to integrate sine squared of x multiplied by cosine to the negative second of x dx. And since this is a definite integral, we're not going to have a plus c, we're just going to have a number. And our answer here is going to be negative pi over 3 plus the square root of 3. And that is your answer. So let me circle that for you. So remember, the vast majority of the trig integrals really just require you to use any number of trig identities. And when I say trig identities, I'm giving a generalization of all the identities: half angle identities, double angle identities, reciprocal identities, Pythagorean identities. That's what I mean when I say trig identities. To rewrite the integrand in most cases, and rewrite the trig functions that you may be given. And that's ultimately what is the hardest part of trig integration for a lot of students, because when you think about it, we're really not applying any specific integration technique to any type of trig integral that we wouldn't apply to an integral that doesn't contain a trig function. It's just memorizing those trig identities. So try to get those memorized as much as possible. You'll need those. So yeah, so that's trig integration. So let me know if you got any questions, and I'll see y'all next time. Y'all take care.